Hello and welcome. We're going to continue on with our probabilities here. As promised in the last video, we are going to be looking at if we drew 4 cards, 3 of spades, a queen of hearts, a 2 of diamonds, and a 3 of clubs. So given that we've already drawn those 4 cards, what is the probability of drawing another 3 in our hand? So we're going to look at that first. So here we have the possibilities. The possibilities are what are in the deck still. So it's not 52 cards anymore. We've got 4 cards out. So our possibilities right now are 52 minus 4. Minus 4. So we need to take 4 away from 52 because we've already drawn 4 cards. So that will leave us with 48 possibilities. So we have less possibilities than if we had a full deck of cards. And the successes of drawing a 3? Well, generally there are 4 3s in a deck of cards. So we would say there are 4, except for, unfortunately, we've already drawn 2 of the 3s. So 2 of the 3s are already in our hand. We can't draw a 3 of spades or a 3 of clubs again because they're already in our hand. So all we have left is the 3 of diamonds and the 3 of hearts. So our successes are literally only 2. There are only 2 ways to succeed in this specific scenario. So we're going to go ahead and write out our probability here. The probability of drawing another 3. And it's going to be the total number of ways we can succeed divided by the total number of options available to us, which is 2 out of 48. 2 out of 48. And so we can reduce this. Half of 2 is 1, and half of 48 is 24. So our probability of drawing a 3 is 1 out of 24. So 1 out of 24, if I were to draw a card, it would be a 3. And so not really great probability there. But that's how you can calculate the probability given that you've already had something happen. I want to see what is the probability of drawing a 3 of clubs and then a 2 of clubs. Ooh, and got a 3 of spades and then a queen of hearts. So it didn't happen, but what are the chances and how often should I expect this to happen from a deck of 52? So the first thing I want to do is calculate the first item that's occurring. So the first occurrence, a 3 of clubs, I have a 1 out of 52 chance of it happening. Right? There's only 1 3 of clubs in the deck of cards, and there's 52 cards. So my 1 success divided by 52 possibilities. Once I've drawn a card and it is now in my hand, there are less cards available to me. So if I were to draw the 3 of clubs, which is of course not likely, but it could have happened, drawing the 3 of clubs. If I've got the 3 of clubs in my hand from the first draw, now I want to see what is the probability of drawing a 2 of clubs for the second draw. And the second draw, there are less cards in the deck because I've already drawn the 3 of clubs. That was a 1 out of 52 chance. So to draw the 2 of clubs, it's out of 51 cards. So there's 1 card that I want out of 51 cards left. 1 out of 51. These two probabilities are intersected. And so that means we need both of them to happen. If you remember from intersections, intersections are ands. So I need to draw a 3 of clubs and a 2 of clubs. So in this case, with this type of intersection, we need to multiply. So we are going to find the probability here, we need to multiply 1 over 52 times 1 over 51. And if you recall from multiplication, we multiply 1 times 1 is 1. We just multiply across. So straight across, 1 times 1 is 1. 52 times 51, so 52 times 51. And we're going to multiply that out. This was an addition step there, so 312. 312. So you can see our probability here of drawing two specific cards in a row, and we're saying we don't replace the 3 of clubs back into the deck after we've drawn it. We don't replace it, we keep it out, and then we draw another. We're going to be multiplying 1 out of 52 times 1 out of 51. And so 1 out of 312 tries, we will probably succeed. But better to say, with thousands and thousands of experimentally doing this, doing it over and over and over, thousands, maybe millions of times, we'd see that it tends to happen once every 312 attempts on average. So our probability here has decreased greatly with this kind of scenario. So we will look at more scenarios later, and there is a small assignment attached to this video, so go ahead and give that a shot. Thank you so much. Have a wonderful day. Goodbye.